Hey, thanks for watching this video. This is type 2 of your EPA 608 exam prep. If you haven't watched the core videos, part 1 and 2, definitely suggest doing that. Other than core though, type 2 is probably the most commonly important, I guess, certification from EPA for the handling, recovery, charging, and purchasing of restricted refrigerants. And the categories have changed a little bit over time about what is restricted and what isn't. Some of this stuff is in flux a little bit because of some recent rulings by the courts, but most of it stays in place. Basically, any refrigerants that you're using that are either a CFC, HCFC, or HFC, including also now modern HFOs, are considered to be regulated, and that means that you have to have a license to purchase them and to charge them and to recover them, and you need to make sure not to vent them. Now again, do not watch this video as complete prep for your EPA exam because everything's changing all the time, and you want to get your preparatory materials from the same company that you take your test from. The two that I suggest looking at are Mainstream Engineering. Go to epatest.com, epatest.com to find out more from them. And then also the ESCO group, which is escogroup.org. They have all kinds of great courses. They have an online course that I would definitely suggest that you look into taking if you're going to be taking the exam through them. And then you can also find some things from rses.org. That's Refrigeration Service Engineers Society, as well as by going to the EPA themselves at epa.gov. And the nice thing with epa.gov is you can get the most recent FAQs, interpretations, and changes and rulings because, again, let's face it, the EPA is a federal agency and there's a lot of things that change in the regulatory environment. And again, if you're watching this, who's to say? I may have made this a year ago, 2 years ago, there may be some things in here that don't quite line up. And so especially as it relates to the modern regulations, some of those specifics, things like leak rate requirements, or even things like recovery levels, how deep you have to recover, those are things you're going to want to make sure that you're up to speed on. And the best way to do that is to go through a testing and prep organization like ESCO or like Mainstream Engineering or whoever you find that you trust. All right, so again, type 2 is what we're talking about. Type 2 covers everything that is not a small appliance that was charged in a factory and has 5 pounds or less. That would be type 1, or isn't a very low pressure refrigerant, sort of like R123 in chillers. So it falls into that middle ground, which is going to be the vast majority of what we work on. Now, another category of certification is the motor vehicle, the MVAC, Motor Vehicle Air Conditioning Certification, which is called Section 609. As of January 29th, 1998, if you have type 2, you do not need a 609 in order to work with the refrigerants contained in motor vehicles. So if you got type 2, you can also work on cars. All right, first and biggest thing is you're not allowed to vent refrigerants. You're not allowed to come up with sneaky ways of venting refrigerants. You're not allowed to punch a hole in a system, call it a leak, and vent refrigerants. You're not allowed to add nitrogen to a system that has a bunch of refrigerant in it and say that, well, you were just doing a leak test. None of those things are allowable. You're not allowed to intentionally vent refrigerants. The Clean Air Act established this on July 1st, 1992. So again, that's the Clean Air Act, July 1st, 1992. Whereas there were refrigerants before that you could vent, like HFCs. After that July 1st, 1992, you were not allowed to vent any of those refrigerants. The only refrigerants that nowadays you can vent are what we would call natural refrigerants. So refrigerants like propane, isobutane, ammonia, those types of refrigerants can be vented so long as that is done safely, but that's not regulated by the EPA in this section, Section 608. The term de minimis is a term you'll hear a lot. Some technicians use it as an excuse to vent. De minimis is not an excuse for venting. It just means a good faith effort when servicing. A little bit of loss will occur. So if you are connecting and disconnecting your probes or your gauges, those sorts of things, or something, a mistake happens where something comes apart while you're working on it. As long as you did that in good faith, you weren't intending to vent, that is considered to be de minimis. You were doing everything the way you were supposed to, and you have a little loss or maybe an accident that occurs that is truly an accident indeed. Those things fall under de minimis. Now, equipment leaks are exempt from 608 as far as the technician is concerned, which means that if you have a piece of equipment that's got a leak in it and you add refrigerant to that, that's not considered to be venting by 608. That is exempt, other than cases where the leak rate is known to exceed the allowable leak rate. And that trigger begins when systems start to contain more than 50 pounds of refrigerant. So if a system contains more than 50 pounds of refrigerant and the leak rate is shown to exceed the allowable leak rate, then certain proactive measures are needed to be taken in order to prevent those leaks. That is not true of systems that contain less than 50 pounds. Now, those of you who maybe aren't from the US, you may say, well, it's different where we are. This is only relating to the current EPA regulations. These things can change. This is just as of my recording of this on 8/16/2020. That's what currently exists, meaning that if you have a system that's got leaks in it, if it contains less than 50 pounds of refrigerant, you are allowed to recharge it. Now, that doesn't mean that's a best practice. That doesn't mean it's the right thing to do. It doesn't mean it's what's best for the customer. Just in terms of EPA regulations, you are allowed to recharge systems that contain less than 50 pounds of refrigerant, regardless of the leak rate. If it's more than 50 pounds, then it depends on the segment of the industry. And actually, let's get into that while we're discussing it. So in terms of leak rate requirements, again, as you can see, this applies to appliances with a full charge of 50 pounds or more. If it's industrial process refrigeration, then if the leak rate may not exceed 30% over a 12-month period. Commercial refrigeration, that leak rate must not exceed 20% over a 12-month period. Comfort cooling and all other appliances must not exceed 10% over a 12-month period if you have 50 pounds or more, which means that you're responsible to keep records, you're responsible to calculate the leak rate over that yearly period, and you're responsible to get the leak rate below that percentage. It doesn't mean that a piece of equipment has to be made leak-free. For example, we work in the grocery store space, which would fall under that 20% commercial refrigeration guideline. There are going to be cases where you have 2-3%, and that's just something you really can't prevent just because of very small leaks through a very large system, but you have to keep it below that 20% per year. And that's where those logs, those charging logs, are really important to make sure that you're calculating that leak rate and you're taking proactive steps to ensure that you stay below that allowable rate. One of the things that changed recently, and this was started in 2016, I believe, but where they came up with a new regulation that applied this also to HFCs, HFOs, refrigerants that have a global warming potential, but not a ozone depletion potential. That's this ODP versus GWP. Now that is in flux, and so I want to show you this recent ruling from the EPA. As of February 26, 2020, so very recently, there was a new ruling that said that the leak repair provisions, the new leak repair provisions that were extended to HFC refrigerants, has now been rescinded, and that only applies to HCFC and CFC refrigerants, specifically refrigerants that have that chlorine in it that causes ozone depletion. If you don't know what I'm talking about, go back to core where we talk about the different types of refrigerants. It's important to remember that tests aren't necessarily written this quickly, so you may be taking a test that still has this older standard, and so you need to make sure that you're being trained by an organization that is also the one giving you the exam to make sure that they're training you specifically on the exam you're taking. This is one of these things. You don't want to completely trust what I'm saying here, but you can pretty much be sure that if the question is asked about leak rate percentage, that you can stick with industrial process, over 50 pounds, 30%, commercial refrigeration 20%, comfort cooling and all other appliances 10%. So again, greenhouse gases, those are things like your HFC and HFO refrigerants. They're still considered greenhouse gases because, according to the EPA, they have a GWP. Those are where some of those rules are in flux. All the rules are still in place as they have been for a very long time for anything that has an ODP, an ozone depletion potential. Those would be CFCs and HCFCs. They contain that chlorine molecule in there. Recovery equipment. So when we say recovery equipment, again, we've talked a lot about this previously, about passive versus active recovery equipment, system dependent versus independent recovery equipment. But just remember that that recovery equipment is required to have low loss fittings on the recovery equipment. That's what the EPA standard says. There is no standard, at least that I can find. Somebody can tell me otherwise if they can find it on the EPA website or elsewhere, that says that you have to use low loss fittings or ball valves on your refrigerant hoses. It's a good best practice, but I don't know that it says that anywhere. I haven't been able to find that, but it does certainly address it on the recovery equipment itself. Now remember, the EPA, when they're talking about recovery, they will sometimes say evacuating. They'll say evacuating in terms of evacuating refrigerant. It's confusing. Even Jackie Chan doesn't understand what's going on with that. Why do they say evacuating refrigerant? I'm not sure. But when they say evacuating refrigerant, they're specifically talking about what we call recovery in the field, removing refrigerant and storing it in an external tank. When we say evacuation, we're talking about pulling a vacuum, which is removing air and moisture out of the system, both removing air and dehydrating the system. And when you pull a vacuum, you want to pull below 500 microns and make sure that it holds. That's a vacuum. When we talk about recovering refrigerant, we're talking about pulling down to a specific level depending on the type of system that it is. So let's go to that chart quickly. So again, you can see right at the top of this chart, it says required level of evacuation for appliances. But if you pay attention to context, they're talking about evacuation of refrigerant, not evacuation as far as pulling a vacuum. Because pulling a vacuum pretty much across the board, need to pull below 500 microns and make sure that it holds below 500 microns. There may be some exceptions to that where you need to actually go a little bit lower. That's the standard when we're talking about pulling a vacuum with a vacuum pump, and we'll talk a little bit more about that. But in terms of evacuating refrigerant or moving refrigerant, you'll see here that there's two columns. One is for pre-1993 equipment, and then one is post-1993 equipment. I'm sorry, the only way to know the answer to the question is to memorize this chart, and I'm not going to spend a lot of time focusing on it other than just pay attention to the less than or more than 200 pounds, because that makes a big difference, this 200 pounds threshold. One thing that a lot of people get confused about, and you'll notice this, is that with most of the refrigerants that we work on, high pressure or very high pressure refrigerants that contain less than 200 pounds, which is the majority of your commercial and residential pieces of equipment, you do not have to pull below atmospheric pressure. There's also a caveat that the EPA has that you don't have to pull a system below atmospheric pressure if it is known to have a leak or if it is a small repair. So when you talk about a major repair would be compressor, evaporator, heat exchanger, condenser coil, things like that. Small repair would be things like a small leak repair or a expansion valve, something like that. And so in those cases, you don't have to pull below atmospheric either. Now, there is no provision in the EPA for not pulling the system at least down to atmospheric levels. And so a lot of practices out there in the field where people will pull it down to 1 or 2 PSI. Again, I know it's common. I'm just telling you the EPA does not allow for it in their information. So if you pay attention, it talks in terms of inches of mercury column vacuum, and that's the kind of the standard. But when you get down to the bottom of this chart, now it talks in terms of millimeters of mercury. So you have inches of mercury column, 10 inches of mercury column, 4 inches of mercury column, pretty much throughout. You have 15 down at the bottom right there in the case of a medium pressure appliance with 200 pounds or more. But when you get into low pressure appliances, they require you to pull to 25 millimeters of mercury absolute. And so they go to a completely different scale there. And so make sure that you pay attention to that when you're talking about those low pressure refrigerants. That would be those chiller type applications, generally speaking. Remember that when you are recovering into a tank, that you need to make sure that you do not fill that tank with more than 80% of the total tank. And so when you're looking at your typical recovery tank, it's designed specifically for recovery. Some of them will have a float assembly inside the tank to ensure that you don't fill above 80%, but we find that that's actually not very common for most technicians out in the field. So you need to be using a scale to ensure that you don't fill above 80%, and you need to do the full calculation, which takes into account the specific gravity of the refrigerant that you're using. Because again, when you look at that WC rating, that water capacity, that is specifically for water, so you have to adjust for the specific density of the refrigerant that you're using. And in some cases, that means you can't go to the full water capacity of weight or even the full 80%. You have to do less than that. And there are many great charts out there that can help you calculate that, but the main thing is do not put more than 80% liquid in a refrigerant recovery tank under any circumstances. And in most cases, that means you're going to need to use a scale. And again, we suggest using a scale whenever you're charging or recovering in all cases. This also comes to account with the new record keeping requirements. Now, again, some of the record keeping requirements may be in flux as well, but as of right now, if you take a system out of service, so if you remove it from service, you need to recover that refrigerant and you need to keep track of the model of the equipment that you removed it from, what address it is, and how much refrigerant you removed before that piece of equipment is disposed. The EPA may ask for those records, so you need to be taking account those records, besides the fact that it's just a good practice anyway. Whenever you are recovering or charging a piece of equipment or putting anything into a tank, you want to be careful of a couple things. Do not mix refrigerants. Under no circumstance is refrigerant mixing a best practice or even allowable, especially in a system. You can't take R22 and put R407C on top of it. That's a common one. People say it's a drop-in refrigerant. Drop-in means, and again, it's still a misnomer, but drop-in means that you can pull all the refrigerant out and put a new refrigerant in, not that you can blend in the field or top off one refrigerant with another. You're not allowed to mix refrigerants in the field, and in the same way, you also want to keep non-condensables out of the system. Non-condensables primarily are air and nitrogen. Sometimes people say non-condensables and they refer to things like solid contaminants or water. Those are not non-condensables in the truest sense. Those are specifically what they are, either water or solid contaminants. When we say non-condensables, we're mostly talking about nitrogen and air. Nitrogen ends up in the system if you forget to completely vent the nitrogen or fail to do so, fail to pull a proper vacuum before you charge, or it can also maybe have been in a tank if you failed to properly evacuate, pull a vacuum on that tank before you put refrigerant in it. So you don't want non-condensables in the system. If you do have non-condensables in the system, that will result in high head pressure or maybe even flux fluctuating high head pressure in some circumstances. One thing that comes up sometimes in the EPA exam is it will talk about open compressors. Open compressors actually have a shaft that comes out that's driven by a separate motor. And so in open compressors, if they've been off, especially when they've been off for a period of time, that shaft seal sometimes will lose lubrication and will begin to leak. So if you have an open drive compressor, watch for leaking shaft seals, and sometimes that comes up on the exam. Before you put a system into service, you always need to use nitrogen to leak test. And again, primarily with nitrogen, you're using soap bubbles in order to find leaks and also watching for pressure drop. Keep in mind that nitrogen does change pressure with temperature. So if you have a giant temperature fluctuation after you pressurize, you need to account for that. And there are many good nitrogen calculators you can use, including the one on the HVAC School app or on hvacrschool.com. Whenever you're using nitrogen, always use a regulator. Make sure not to overpressurize beyond the test pressure for that particular side of the system that you're pressurizing. Especially be careful when pressurizing a compressor, because the actual shell of the compressor is on the low side, and sometimes those fusite terminals where you make the electrical connections can be a weak point and can blow out when a system is overpressurized on the low side. When recovering refrigerant, liquid phase is the fastest way to pull refrigerant out of the system. There are many good recovery machines nowadays that allow you to put full liquid into the machine. Some of them can actually handle pumping liquid, some have to meter it through, but some people choose to recover in vapor phase in order to save oil, because when you're pulling liquid refrigerant out en masse, you do bring more oil with it. Modern oils are miscible in the liquid refrigerant, and so more oil is going to come out when you pull it out in liquid phase. So just think about that and whether or not that's a critical consideration, or whether or not you're going to adjust your oil charge. In order to speed up recovery, one of the best things you can do is to chill the tank that you're recovering into. Again, you have to make sure you weigh it still, and so sometimes that can be tricky if you're putting it in the bucket of water, but you want to keep that tank as cool as possible, so that way liquid refrigerant will go in more quickly. Still, make sure not to fill it over 80% liquid. If you're using a water-cooled recovery unit, so some recovery units will have a water-cooled condenser, which help them remove refrigerant much more quickly. If you're using a water-cooled recovery unit, which would mostly be in larger applications, you're going to use the municipal water supply. Don't use water from the cooling tower or something like that. Use the municipal water supply. That's something that comes up from time to time on the EPA exam. Recovered refrigerant can be reused for the same customer and the same property, but that's the only circumstance. You can't take recovered refrigerant out and put it in somebody else's unit out there or sell it on the open market. That's not allowed. It has to go through a registered, certified reclaim facility. Again, that's that recover. That's when we take it and put it into a tank. Recycle is when it's processed in the field, and then reclaim is when it's actually sent back to a facility. In order to resell, it has to be reclaimed. When you are looking at a system for leaks, so when you're doing maybe you have a system that's leaking a lot, the first step we always recommend is to use your visual inspection and look for signs of oil. Many times leaks will show up in signs of oil, and you can often use soap bubbles along with whatever the standing system pressure is, or if the system is flat, you can use nitrogen to pressurize it up. You can use a trace gas, and the EPA specifically allows small amounts of R22 to be used as a trace gas. I haven't read a lot on this recently, whether or not other refrigerants are allowed nowadays that R22 is being phased out. This is something you're going to want to follow the specific guidelines from the test organization that you're working with, but it is common to use a very small amount of trace gas in order to be able to use an electronic leak detector. But that does not mean you can put nitrogen on top of an existing charge in order to find a leak. You must fully recover to the required level, which if a system is known to be leaking, that would be 0 psi or atmospheric pressure. And then finally, one thing I want to mention, which comes up from time to time, just good knowledge, filter dryers. Filter dryers are there specifically to remove moisture and to remove solid contaminants. They cannot remove air. They cannot remove nitrogen. So if you're talking about air and nitrogen, that has to be part of pulling a proper vacuum. In order to pull a quick vacuum, we've made whole videos on this, which I suggest that you watch, but you need to use a micron gauge located far away from the pump, large gauge hoses with your cores removed in order to pull a vacuum consistently every time and do it quickly enough to be practical. Many people get frustrated with vacuum because they're not using proper processes, and so it takes too long and then they don't end up pulling a good vacuum. But you need to use a proper micron gauge attached far away from the pump as you can at the system, at large hoses for your evacuation, and evacuation specific hoses if at all possible, and have those cores removed so you have minimum restrictions and maximum speed on your evacuation. But remember, again, EPA calls evacuation, sometimes they're talking about evacuating refrigerant, and sometimes they're talking about pulling a vacuum, which is where you pull those non-condensables and that moisture out. But a filter dryer specifically is for solid contaminants and for dealing with moisture in the system once it's up and running. So a couple of those kind of strategies to help make sure that you don't have moisture or air in the system, because both of those are system killers. So that's all I've got for type 2 for now. I know this was a longer one than the others. Work to make sure that you study for type 1 and type 2, take some test exams, read the guides, watch the videos from whatever testing organization you're using. Again, a couple really great ones: ESCO, Mainstream Engineering, RSES, and then always keep an eye on what's out on EPA.gov to make sure that you're up with the latest information. Hopefully you found this helpful. We'll catch you on type 3, which is going to be the last one in the series, and it will be a shorter video, I promise.